Dipoles are an electromagnetic phenomenon which occurs when an electric dipole deals with the separation of the positive and negative electric charges found in any electromagnetic system. Magnetic field lines are a visual representation of a magnetic field, showing the direction and strength of the magnetic force at any point in space, with the density of lines indicating the field strength. The magnetic flux is the number of magnetic field lines passing through a given closed surface. It provides a measurement of the total magnetic field that passes through a given surface area. Magnetic domain is the macroscopic region within a magnetic material where the atomic magnetic moments are aligned in the same direction, contributing to the material's overall magnetic properties. Ferromagnetism is a physical phenomenon, long-range ordering, in which certain materials such as iron, cobalt, and nickel strongly attract each other. Paramagnetism is a form of magnetism whereby some materials are weakly attracted by an externally applied magnetic field and form internal induced magnetic fields in a direction of the applied magnetic field. The electromagnetic spectrum is a range of all types of electromagnetic waves, organized by wavelength and frequency.
The types of EM waves can include radio, microwave, infrared, visible, UV, X-ray, and gamma rays. The energy and frequency of these waves are determined by its wavelength. A longer wavelength results in a lower frequency and lower energy, for example, radio waves. A shorter wavelength results in a higher frequency and higher energy, for example, gamma rays. Longitudinal or compressional waves are a type of wave that cause the particles of the medium to vibrate parallel to the direction the wave travels. When the particles are close together as seen in the model, this is called compression. On the other hand, when the particles are spread apart, it's called rarefaction. In contrast to longitudinal waves, transverse waves are a type of wave that cause the medium to vibrate perpendicular to the direction of the wave's travel. Mechanical waves are waves that must have a medium to carry energy. These type of waves can be either transverse or longitudinal. A common example of a mechanical wave are sound waves. EM or electromagnetic waves are waves that do not need a medium to carry energy. Unlike a mechanical wave, EM waves are always classified as transverse waves. General examples of EM waves include light, X-rays, gamma rays, radio waves, and microwaves. The anatomy of a wave includes 4 different characteristics. First off is the wave crest. It's the highest part of the wave. Second is the wave trough, the lowest part of a wave. Thirdly, the amplitude is the vertical distance from the center line to either the wave trough or the wave crest. Lastly, the wavelength is the distance between 2 consecutive wave crests or between 2 consecutive wave troughs. Period is the amount of time, usually measured in seconds, it takes for a wave to complete 1 full cycle. The formula for period is T equals 1 over F. As you can see, T represents period, which is measured in seconds, and F stands for frequency, measured in hertz. Frequency is defined as the amount of cycles a wave completes in a certain amount of time. In this case, 1 second. As you can see, the formula for frequency is inversely related with the formula for period, with frequency equaling 1 over the period. In addition to the formulas for period and frequency is wave speed. As the name implies, wave speed is used to calculate the speed of a wave, represented by v, and measured in meters per second. The formula uses frequency and wavelength to find the speed.